Hello, this is Jürgen with the FIBO Data Model training, and today's Semantics for extra large banks is an overview into the semantic enterprise information architecture and model-driven development with the industry standard ontology at the apex. So the first part is a dive into the model, and the second part covers the configurable ontology to data model transformation COD. And now the presentation and this video is a new recording, and it has been updated for OMG Commons and for FIBO loans. Your financial institution embraces RDF OWL and the FIBO. You have already or are moving towards Semantic Technologies, Centers of Excellence, and RDF triple stores. You use and support the development of the industry standard ontology, and you have licensed or downloaded and evaluated the FIBO data model. So the COD patent US 120383939 enables full disclosure of the transformation technology. What are the challenges for a Semantic Center of Excellence? Many global banks already implemented, extended, and customized the industry standard ontology. However, 95% of the bank still runs on RDBMS, and architects are using data models to design the relational databases. Now, the global banks have highly qualified ontologists and data scientists. However, data architects who have the FIBO model can leverage the work of their colleagues in the Semantic Center of Excellence. So the risk is that semantic implementation become yet another data silo, using a different language from the rest of the organization and impeding integration of semantics and conventional systems. FIBDM and COD are the bridge across that chasm. So we have the customized FIBO ontology knowledge graph in your data modeling tool in Power Designer or Irwin and other tools. The vision is Semantic Enterprise Information Architecture, SEIA. Now, when we look at architecture, we can differentiate by the use. Is it for business, design, development? By the type of the artifact. Is it conceptual, logical, physical, or is it implementation? And we can look at the level where it applies. Is it enterprise-wide, departmental, or for individual projects? And today we already have conceptual and logical data models that we physicalize and that we deploy on RDBMS. And you likely have XSD for messages, BPMN for processes, and you have UML for object models and generating code. Now, what is new is we have the FIBO in RDF OWL, and that deploys on RDF stores. And with FIBDM, we have the FIBO as the conceptual data model. And we can also generate other models like UML out of the FIBO. And finally, there is FIBCM, the concept maps, and they are a simplified diagram for business users that we keep in sync with the data model and ontology. And bi-directional model transformation enables semantic enterprise information architecture. So here on the left-hand side, we have the OWL with the FIBO, other industry ontologies, and our own proprietary ontologies. On the right-hand side, we have FIBDM, we have enterprise and project data models. And in the middle is Atlantic CODT, the transformation technology. And we generate data models from the industry domain and proprietary ontologies. And we design conceptual models in RDF-OWL. And in reverse, we use our data models to extend the enterprise and project ontologies and the knowledge graph. So how does this lesson here, Semantics for Extra Large Bank, fits into the overall FIBDM training schedule? So you should have completed the first 3 lessons, no? Semantics for managers, for project architects, and in particular for finance users, which is a deep dive into the 15 FIBO concepts. And then here you see it's branching a little bit. No? So we have 3 lessons for mid-size, large, and very large banks. However, the classes are fully applicable to all financial institutions. No? So mid-size banks means, yeah, smaller banks with no semantic technologies yet. Large banks, many has an open banking example. And our presentation here, extra large banks, is for institutions who plan to customize the FIBO. Well, and the titles are for banks, that's for historic reasons, but the content here of all 3 modules is fully applicable to other financial institutions like investment funds. So every bank is different, and in practice we usually cover all 3 lessons and just move faster now when the content repeats or is not critical. The asset size is a poor proxy for semantic sophistication. Now, Semantics for Data Architects, the name of the very first FIBDM education resource, became a catchphrase. And the first part of our presentation today is a shorter dive into the data model. And FIBDM on the EDMC website was originally for financial institutions with less than 200 billion in assets, hence semantics for mid-sized banks. However, some financial institutions like hedge funds, for example, are very advanced. And some larger banks on FIBDM are just now building out ontology capabilities. And the second part of this class is an overview of the transformation technology CODT, which is for financial institutions that use and extend the FIBO. Not many, but not all are very large financial institutions. Yeah, who is this class for? For general audience, no? Finance, management, business stakeholders, no, have some working knowledge of entity relationship and ontology diagrams, no? And you should be authorized to sign non-disclosure and license agreements if you want to do a CODT POC. However, you can skim the pages that deep dive into FIBDM and CODT. Now for the POC, in particular ontologies, no? With an in-depth understanding of the FIBO and in-house ontologies. So you want to spread the adaptation of the industry standard of your ontology work across the enterprise. And you're well versed in RDF-OWL and Sparkle. And data architects with experience in enterprise reference models, you evaluated and want the industry standard FIBDM, and you're an expert in your data modeling tool and its import functionality. And finally, developer, MS Excel power users, experience in VBA, Power Query, and the M language. Now about myself, well, I worked in finance for 20 years as a data architect and ontologist at leading financial institutions and service providers. And in particular, for 7 years, I was an IBM Software Group consultant for their banking and financial markets data warehouse, the BFMDW, and in that capacity, I was teaching the IBM model at some 45 banks in North America, Europe, and Asia. And afterwards, I consulted Citi and Deutsche in implementation, and I've been a contributor, reviewer, and speaker at FIBO conferences since the beginning. And JZ Data Models, my company, is a US consulting business, and it has been incorporated 25 years ago. And JZ holds the 50M copyright and is the designated assignee of the CODT patent. The two standard setters, the EDMC and OMG, collaborate closely. The EDM Council is a member-driven trade organization dedicated to data management and analytics as a strategic business priority. So founded in 2005, they provide best practices, standards, education to data and business professionals. And the Object Management Group is a standards development organization. It's global, a non-profit consortium. And here they say our members collaborate to craft technology standards that offer measurable value to a diverse range of vertical industries. Now, so notable, the OMG is across all industry, whereas the EDM Council is specialized in finance. Well, and now the EDM Council and Object Management Group have merged. The EDMC has over 200 financial institutions as members. And they teach data management best practices, develop data standards, and you probably did the EDMC's data capability assessment model already. No? And in particular here, the EDM Council is the publisher of the FIBO. And the Object Management Group with over 220 large member organizations develop well-known standards like UML, BPML, DDS, and SysML. And in particular, the OMG developed the Commons Ontology Library. Well, and effective October 1st last year, the Enterprise Data Management Council acquired the Object Management Group. And the combined EDM Association is the world's largest non-profit trade standard setting body for data management. So FIBO and OMG Commons, the financial industry business ontology defines things that are of interest in financial business applications and the ways that they relate to each other. And by doing this, the FIBO gives meaning to any data. No spreadsheets, RDBMS, XML documents that describe the business of finance, and hence the ontology knowledge graph. And the Commons Ontology Library is a set of small ontologies designed to provide modeling constructs that are reusable in different modeling and data deployment environments. And OMG Commons is designed as a foundational or upper ontology independent of the domain or industry. Now the FIBO imports OMG Commons, deprecating foundational classes in the foundation modules. So in other words, OMG Commons entities have replaced FIBDM entities in the foundation business entities and finance, business, and commerce modules. The FIBO is more than a knowledge graph. The EDM Council and its members, the financial institutions, decided to define their business conceptual model in ontology web language OWL, because OWL has superior semantics. FIBO conceptualizations and relations are fully applicable for lower semantic taxonomies, concept maps, object and data models. And FIBDM is a perfect conceptual data model for the enterprise and for projects. And you can read in more detail about this statement in the article about comparing ontology to data model hierarchies, and the second article that explains why ontology object properties should be associative entities in a data model. Well, the EDM Council features FIBDM on its website, and more than 3,500 users already downloaded the open source version of the FIBO data model. And many EDM association members want to leverage the standards but don't have ontology tooling, databases, and the human expertise in-house yet. And with FIBDM, data architects no longer manually transcribe ontology graphs and copy and paste definitions from the ontology into the data modeling tool. However, even with FIBDM, architects at larger financial institutions must still copy and paste FIBO customizations and extensions that the ontologists in the Center of Excellence developed. The FIBO is superior to vendor data models.
Le roi est mort, vive le roi.
No, so it was almost 600 years ago. No? Robert II Duzé proclaimed Charles King of France. And still, the involved party remains an ultimate supertype across numerous reference models and databases. OMG Commons breaks the commingled entity into two fundamental concepts: the agent, person or legal entity, and the role that it performs as customer, counterparty, borrower, employee. One agent, many roles. Yeah, so here we see the agent and then its role, two different concepts. Now, and altogether, there are 15 concepts. They all have a name, an icon, an abbreviation. And these are fundamental to the business of financial services. There are the top-level ontology classes defined in OMG Commons. And they are ultimate supertypes in the data model. 90% of FIBDM entities are a subtype of a concept entity. And here, just a brief rundown here, the situation, that's contracts and commitments. Designation, all IDs. Constituent, detail, a contract. And collections are used for any links or groupings, no? Like, for instance, payment schedules are collections. Aspects add characteristics. Specifications are technical documents, formulas, expressions. Arrangements are codes. Measures is what we observe in the real world. Occurrences is the concept under which we have transactions. Temporal entity, dates and times. Documents, scalar quantities, dollar amounts or euro amounts, numbers and percentages, and of course the account. the ontology-derived data model. On the left-hand side, we have an ontology graph from the FIBO. We see here it shows a bank account identifier, which identifies a bank account, and the bank account is provided by a bank, which is a subclass of a depository institution. And on the right-hand side, we see the derived conceptual data model. And here we see classes transform into entities. The subclass in the ontology transforms into data model inheritance or subtype. And object properties transform into associative entities, not relationships. And finally, the relationships between base entities and associative entities, here the cardinalities, they derive from class restrictions, domain, and range. And this mapping diagram actually is figure 1 of the CODT patent drawings. Yeah, and the current tooling imports of RDF OWL files are not fit for the purpose. No, so some data modeling tools have a rudimentary import for RDF OWL files, but these imports are usually a one-click black box with no options or diagnostics. And some use the URI as entity names, and some convert data properties into classes, and class restrictions become anonymous pseudo entities, and that doesn't help the data modeler. And there's no import of annotation properties. Yeah, and the challenge is that the parsing approach is not scalable. Not traditional transformation parse ontology files, so they go file by file, encounter elements of the ontology, and create elements in the data model. And the parsing approach reaches its limits with very large ontologies like the FIBO. Now the FIBO has 250 RDF OWL files, and some tools crash. So by default, object properties transform into model relationships, and this transformation loses metadata, loses the semantics for object properties with design patterns like sub-properties. No? The OMG and FIBO have a deep hierarchy of object properties that must be transformed into a hierarchy of associative entities. And some large financial institutions develop rudimentary transformations. However, I invite you to compare FIBDM with any vendor or in-house FIBO transformation to see the difference. And license the patented technology that created the industry standard model rather than reinventing the wheel and do it yourself. Yeah, let's look at the outcome of the transformation. And here we can start with package properties. And just a note, you can import the Power Designer model into Irwin. And Irwin provides everything you see on these slides as Irwin user-defined properties. So first there is the package name, and that is the rightmost string in the ontology namespace. So here we have loans, and we have the code of the package. And then CODT transforms the ontology prefix into Unicode, and the comment derives from the definition in RDFS comment or the SCOS definition. and all ontology classes, properties with the same prefix, in this example FIBO, foundation, agreement, become model objects then in the agreement package. And finally, at the bottom is the URI of the ontology. So the uniform resource identifier is a hot link, a traceability into the source of the model object. In other words, it points to the FIBO ontology or FIBO class. And now this second part of the overview shows how CODT extracts and transforms and adds these properties to the model. But let's continue with the FIBO Power Designer model package documentation or subject area documentation in Irvine, derived from the FIBO OMG ontology annotation properties. And here we have a table of the packages and the number of annotation properties that they have. We see like most packages have a label, and OMG comments, parties, and situations also provides a contributor and a node. And license, change node, copyright, maturity are on the lineage tab. Yeah, package lineage. So the ontology namespace provides the resource name of the data model package. Now here in this case, CMNS-PTS, that's commons, ontology, libraries, parties, and situations. And it's then a prefix for all entities in that package. So all OMG Commons packages have an abstract. And the copyright box lists the JZ FIBDM copyright and all copyright notices in the source ontology. Yeah, and the depicted data model license for the full commercial version here is your intellectual property license agreement, whereas the open source version is licensed under GPL 3.0. The ontologies are licensed under the MIT open source license. So the open source licenses and the JZ IPLA require that all derived work must include the license and copyright notices. So in other words, make sure to include these nodes in your FIBDM migration to other tools, generated logical, physical, object models, and all metadata extracts. So entity properties. The name is derived from the ontology class local name, and it is converted from the camel case notation in FIBO OMG to logical data model naming convention. Also, so we have the first letter capitalized and a space between the words, like we usually do in our data models. And the code transforms from the ontology class local name. The comment populates from the class annotation, the RDFS comment, and SCOS definition. There are two particular tabs here for annotations and lineage of a data model entity. So the data model annotations come from the extensive FIBO documentation. And here's a chart that shows the number of classes with annotated documentation. So again, here we see almost all have a label, a definition, and a lot would have an explanatory note, not an abbreviation. Some may have a synonym. So in here again, not all annotation properties are populated in the FIBO. So also here on the annotations tab in the data model, some of the boxes remain empty. Yeah, and the lineage tab captures the ontology metadata of the source class. So in Power Designer, we have extended attributes that provide traceability into the ontology and preserve semantics that we cannot model in the entity relationship data model. And just a note, in Irwin, these attributes are on the entity as user-defined properties. So we have the resource name, which is a combination of prefix and local name. And FIBDM uses the resource name as the entity code, but you can generate your codes in the modeling tool. And the local name is the rightmost string in the resource name in URI. The prefix is an abbreviation of the URI defined in the ontology. So here in this example, FIBO Foundation Agreement. That is the FIBO ontology that defines the obligor. And the uniform resource identifier of the class, this is a direct link into the FIBO source ontology. So we have complete lineage and traceability from our data model into the source ontology. Yeah, and finally, restrictions and equivalent class axioms formulate our semantics. And this is typically something we cannot define in the data model. No? So here, that obligor is a role on an agreement that is a commitment and played by the obligor who has that obligation. So how does CODT transform complex ontology patterns? So here at the bottom we see a loan which has a principal amount, and that is a loan principal. So that's pretty simple because here we just have to deal with range and domain. However, that has principal amount, that data property, is a subtype of has notional amount, which is a subtype of has monetary amount. And in the ontology, these parent properties are also have relations, no? And some can be complex class restrictions. For instance, here the has notional amount is either a monetary amount or a percentage amount. And likewise here we have a class restrictions for the CD, the certificate of deposit, which has exactly one notional amount, which must be a monetary amount. And so that's where we see that preserving the full FIBO semantics is where rudimentary transformation failed. So how does FIBDM represent this ontology? So yeah, we need a sophisticated data model transformation. So it is wrong to simply use data model relationships as a result of a object property transformation. We must use associative entities so that we can preserve and model the hierarchy of ontology object properties, no? From principal amount to notional to monetary amount. Yeah, the FIBO, how does it work with your vendor and in-house models for semantic enterprise information architecture? So our goal is to leverage for implementation, no? Be it databases, be it code, and be it for the department, the project, or individual applications. And our method is to derive. So we adhere to the industry standard. We use the FIBO production ontology. We can scope enterprise and project models, and we consult the other models that we have. No? Our customized FIBO, other standards, and in-house data models and ontologies, including vendor models. Now, and DAs should merge the vendor and in-house models into FIBDM. No, because it has excellent value. No, so keep it and harvest the content. So we adhere to the industry standard, the 15 concepts and the subtype hierarchies. We adopt the FIBO and FIBDM names and definitions. And then we identify direct entity matches, synonyms. We identify entity matches, and we beware of homonyms, not where we have two names for the same thing. We merge entities that are not already in FIBDM. We identify the appropriate supertype. No? So, for instance, if you have other types of contracts, and then we merge attributes from your vendor or in-house model into FIBDM. Because the FIBO and FIBDM are conceptual models. Now, the FIBO has very few data properties, and hence FIBDM is largely at an entity level. So, and note here the FIBO data model correctly defines financial instruments as a subtype of the contract, not an agreement, not a product as some vendor models do. So the concept maps FIBCM directly correspond to the data model. No? On the left-hand side, we have a concept map about financial institutions, depository institutions registering with the FDIC, and that they have a legal entity identifier, physical address, and have capital. And on the right-hand side, we see the corresponding data model. No? And we can, in the FIBDM, then scope, grab the entities that we have modeled with the user in the concept map. And also, ontology and data model are in sync. No? So here, the data model here about the stock corporation and the address is equivalent to the ontology graph. And beyond data, object property range and domain, the ontology transformation infers relationships from class restrictions. Now, here from the OMG Commons legal entity. Yeah, so a brief comparison, the GPL 3.0 versus a customer license. Now, in the open source, you must copy left, that is, license your derived models, your model migrations to the public. And with the commercial license, you keep FIBDM migrations and extensions private. And likewise, all the public education materials are subject to copyright. And with the commercial license, you're free to modify, translate, edit, and even lift off images and diagrams as long as they remain within your organization. No? And also we can see here the open source version is based on FIBO 2018 Q4, whereas the latest full version of the data model is of 2025 Q4, and we see that it has 2,000 additional entities. Okay, in summary, so with currently 3,173 entities, it's the world's largest reference model for financial institutions. It has a superior design as a semantic data model. It has extensive documentation of the industry standard ontology. It has a full lineage into the source, and it facilitates semantic enterprise information architecture. We have same names, definitions, and design patterns across the enterprise, and we put the ontology at the apex and include business-friendly concept maps, derived data, and object models. And with that, we unify semantic and conventional data management. Full transparency for your FIBDM evaluation. You can download the FIBDM core version, which is open source, and explore the model in your data modeling tool, Power Designer or Irvine. You can study the extensive education resources and watch the other videos in the FIBDM training course on YouTube. Can examine the full 2025 Q4 model content, which has the definitions of all entities in the data model. Well, and finally, review license maintenance and pricing. Well, thanks for watching. This concludes the first part, and you can continue with the video for part 2, which dives into the transformation technology.